Hello and welcome back to Black Hole Battles game development. I've made a couple of additions to the game since last time. One of the things I've added is an entry point for the level that currently looks like this big purple circle engulfing my ship. That will be a much better graphic when I have better graphics to replace it with. This is the starting zone for the player ship. It's a gravity-free zone, so right now the ship experiences no gravitational force from any of the nearby black holes. It can still get bumped by the enemy ship should the enemy ship try to do that, but right now this ship is trying to just avoid black holes. And this gravity-free zone will stay until my ship leaves it. Once my ship leaves it, it's going to flicker and disappear. I said flicker and disappear. Okay, I'm not quite sure why it's not disappearing. I'll have to take a look at that later. But I've also added in, there it goes. Okay, maybe I hadn't quite cleared it yet. Maybe I need to change its, maybe I need to change its size that it considers. Yeah, there it moved. Okay, well that was weird. I've also added in these other pink dots that you see, that you have seen. Oh dear. Let's see. Yeah, there it disappears. Okay, I'm not sure what happened that first time. Yeah, these pink dots. These are the ones I'm talking about. This is what's called Matter. This is part of the storyline of the game. This is the stuff that you're trying to collect to get you from one level to the next. There's not really any physics associated with them. In fact, in the story, they basically violate the laws of physics because they're not affected by the gravity of the black holes. In fact, in the story of the universe, they are used to cancel out gravitational effects, which is not based on any physics we currently have. But as the storyline will say, you'd be surprised how quickly physicists can discover something when the fate of the galaxy is at stake. But you notice I've put in a little counter here to tell me how much matter I've collected, or IM is how it'll appear on the little scorekeeper. But I went ahead and did those off camera just because there's no physics associated with that, so I didn't want to make a video about just adding in a couple little counter things. I've also got a timer displaying now to show me how long the enemy ship lasts. So if the enemy ship falls into a black hole, it will tell me how long during the game it lasted, just so I can get an idea of how well the enemy ship navigation routines are working. Because if the ship is only going to last 30 seconds on its own, that's not a very interesting game, I don't think. That time it lasted 17 seconds, but that's because I was firing on him. What I'd like to look at today, I've been focusing on the enemy ship controls because I want to get to a point where the game is able to be picked up and played by somebody so that I can get feedback on how the game is handling. And that requires having a formidable opponent. Right now, the enemy ship, all it's doing is avoiding black holes. There's really not much else for it to do, and most importantly, it's not aware of the player ship. So, for example, I can come up right next to the ship, and he does absolutely nothing in response to me. He completely ignores my existence, and I kind of find that unsettling, personally, but it's also, not the best for gameplay. And so what we're going to work on today is adding in an evaluation of whether the enemy ship is being chased by the player ship. So what I have in mind is, let's suppose the enemy ship is over at this point, and the orientation of the enemy ship I don't think actually matters in terms of this evaluation. And then let's suppose we have the player ship over here. I want the enemy ship to be able to tell whether the player ship looks like he's chasing after the enemy ship. So, for example, actually, I'm just going to call them player and enemy, because adding ship onto the end of a word is actually kind of difficult. At least for my southern mouth, it is. So, for example, if the player ship is pointing, in this range of directions, I think it's pretty clear that he's either chasing the enemy or he is, or at least he's about to, or at least he's considering it. If the player is pointing in this direction compared to the enemy, then it's pretty obvious he's not chasing. He might be coming around for a chase, but the enemy can basically do whatever he wants at that point because the player is not chasing him. But then what if the player is pointing, say, in this direction, kind of perpendicular to the relative position vector between player and enemy? He might be chasing, he might not. That kind of depends on how the enemy interprets the player's behavior. And so we can start to make this a little bit more mathy. What I have in mind is what I'm going to call a cone of paranoia. I'm enjoying naming these cones. It's kind of fun. Basically, the wider the cone is, the more paranoid the enemy is. So, for example, if the enemy has a very narrow cone of paranoia, then he's not too worried about the player. The player could be pointing, in this direction, and the enemy is not concerned about him chasing him. But if the enemy's cone of paranoia was wider, like let's say that the cone of paranoia was 90 degrees, going out this way, the player could be pointing anywhere from out here to over here, and the enemy would say, oh no, I'm being chased, I have to get away from the player. And so depending on the aggro level of the enemy, this paranoia angle could be larger or smaller, just depending on the tactics of that particular enemy ship. It's going to give us another dimension to play with in terms of the enemy's behavioral patterns. And so what we need to do is we need to assign a paranoia angle, which will increase with paranoia. That's why it would be called a paranoia angle. We need to define the relative position vector, that's this long arrow in the middle here, between the player and the enemy. So that vector has nothing to do with direction either of these two is pointing. It's strictly based on their position, so enemy.pos minus player.pos. And I'm using scriptar there in honor of my electromagnetic theory class that I'm teaching this semester, where Griffiths uses the scriptar to indicate the vector that goes from the point you're starting at to the point you're going to. That's basically what scriptar means. If you're in an E&M class, I hope that was helpful. So basically, the enemy ship is going to consider himself chased if the player points within that cone. So if the player's angle, if the ship points anywhere in this cone, then the enemy says, I'm being chased. If the player points outside this cone, the enemy says, no, I'm not being chased. We're not yet determining what the enemy is going to do in terms of his behavior based on this information, but today we're just going to make it so that the enemy can gather that information. And so we need to turn that evaluation into a mathematical statement, and basically we need to take the player angle, which we already know how to do. We've already done that with the enemy angle, so we just have to do that with a player angle. We know how to get the angle that the ship is pointing at, minus the scriptar angle, minus the angle of this relative position vector here. And basically what we'll do is we'll take the absolute value of the difference and evaluate whether that is less than the paranoia angle. And so basically we're going to use this later to determine the enemy behavior. So I'm going to need to add a public game object. Let's call it player here. And if I recall correctly, that should bring up a field over here for me to drop into. There it is, the player. Okay, good. And so basically what I do is I click and drag ship over. Actually, so I don't want to select it. I want to go to other ship, and then I want to click and drag this thing to player. So there we go. So now we've got the ship assigned to the player value over here, which is good. And let's see, where should this evaluation happen? I mean, obviously it needs to happen before we call a behavior. So actually it should happen around here where we evaluate the safety speed and the RMin want and all of that stuff. So let's do this. Let's make this the section. This is where you determine the enemy's behavior. And let me zoom in there for you on the YouTubes. There we go. Okay. And so we also need to declare let's see, I guess we'll make it a private. I don't know that we'll need to access anywhere else. If we ever do, we can just make it public instead, or static public, excuse me. Let's see here. Where do I determine the RMin want and all that? Oh, I do that in here. Okay. Let's declare it the same way we declare Armin want? Okay. Okay, cool. So that would be a bool. So Boolean is the logical variable. Am I being chased? Actually, let's call it being chased. There we go. Because then if being chased equals true, then we know we're being chased, and if not, then we are not. And let's go ahead and set that equal to false. Evaluates whether enemy is being chased by player. Cool. All right then. Then we need to start getting this information from here. Okay, so the first thing we need is the player ship angle. So let's see. How do we get the enemy ship angle? Okay, so we go through all of this business. The ship's current orientation angle. Okay, cool. So we've already got the ship's angle, which we don't need. Let's see. Okay, we gather that in the next nearest black hole. So let's copy that and paste that into here because it takes care of all of the Euler angle rotation business and takes care of all of the adjustments based on the ship's orientation. Oh, although I am going to need to change this because my player ship initially points upward. But we will figure out how to do that. So instead of ship angle, let's call this player angle. And let's see. So we're going to need this to be player dot transform dot rotation dot Euler angles dot z. And then we'll change all of these ship angles to player angles. There we go. There we go. There we go. Okay. And now I'm going to have to adjust some of these values. So let's open up a new whiteboard. Because I'm going to have to adjust these values based on this thing, based on the player ship. So the player ship, when it comes out like this, so here's player. That's not very good. So here's the player angle. There we go. So let's see here. C# likes for everything to run from 0 this way to pi this way. Actually, let's not call it pi. Let's go ahead and, because we're already going to do the. Oh, excuse me. Yeah. Let's go ahead and label in terms of degrees. Likes for that to be 0, that to be 90. And then it likes for, so it likes for everything going this way to go from 0 to 90, and it likes for everything going from this way to go from 0 to negative 90. Oops, excuse me, that's not 90. Silly me. That is a 180. There we go. Pin. There we go. That is definitely a 180. So it would call this one 90 degrees, and it would call this one a negative 90 degrees. But the problem is, so that's C#. So we'll have C# being black there. But the problem is Unity. Let's see. Unity seems to like the bluish gray. There we go. The difference is that Unity calls this thing up here 0 degrees. And then rotates around this way to get to 360. All right, I'm using my finger, not the stylus anymore. So it would call this one 90 degrees. It would call this one 180 degrees. And it would call this one 270 degrees. So that's Unity's preferences in the blue. I believe, let me double check that. So for example, this thing is pointing, my ship is pointing upward now. If I increase its rotation, excuse me, I rotate it negative there. So let's say I rotate it to be positive this way. then okay, yeah, it's rotating positively. So if I make that if I make that a 90 degrees, it points that way. If I make it to 70, it points that way. What's natural for it though? Whoa, okay. Ooh, that's cool. I did not want to do that, but okay, there we go. Okay, yeah, so it does go 0 to 360. It doesn't naturally do any negative angles. Oh, maybe it does, because it just went past 360. All right, let's put everybody back to 0 where you belong. So if I rotate this thing this way, okay, it is willing to accept a negative there. Okay, so we'll have to play around with that a little bit. Okay. So I need to come up with a nice linear relationship between these two angles. So I guess let's go to red now for the math. I always put my math classes into red notebooks. I don't know why. So for this guy, let's see, we're trying to convert from Unity to C#. So the C# angle is equal to, for this point here, the Unity angle plus 90. Okay. And then this one over here, the C# angle is equal to the Unity angle plus 90. Right, because I'm going the black one equals the blue one plus 90. What about this one? Here we run into a little bit of an issue. Here the C# angle is equal to the Unity angle. So the black one equals this one minus 270. This one over here, the C# angle, which is 0, equals the Unity angle minus 270. Okay, so I've got two possible relationships here. So the question is where I need to cut them off. I think I need to cut them off along the 0 to 180 line, because that's where this thing goes to being negative. Okay, so this relationship is true. This first one is true if the if the Unity angle is, because Unity angle is my input. So this one is if the Unity angle is is between 0 and 90, or if it's greater than 270. Cool. And this one is true otherwise. Yeah. That's an easier way to say it is otherwise. Actually, I guess the way to say this one is if the Unity angle is between, these are my less than signs, please don't mock them, is between 90 and 270. Yeah, okay, that's going to be the easier way to do that. So if the Unity angle is between 90 and 270. Okay, so let's set that up. So if player angle is between 90 and 270, player angle is greater than 90 and alright, so greater than 90, less than 270, greater than 90, less than 270. Then I need to add 90 degrees to it. Yes. So then we add 90 degrees. Oh, excuse me. No. I'm looking at this one. Excuse me. So then we take away the minus 270. Cool. And otherwise it needs to be this one. Oops. And that is where we add 90. Okay, so let's double check that. So greater than 90, less than 270. Greater than 90, less than 270. Subtract 270. Subtract 270. Otherwise, add 90. Otherwise, add 90. Okay. Let's do this now. So that's going to give me in degrees the player angle. So let's have it print player angle. Save. Oh, excuse me. That is not how print works here. I've been in Python a bit too much lately, I guess. Okay. Save. All right, all of our rotations are back to normal. All right, let's hit play and let's watch the console. Okay, currently I am at 90. Yes, that is a 90-degree angle as far as C# is concerned. If I rotate this way, oh, I get a 430-degree angle. That is not what I was looking for. Here I get a 120-degree angle. Also not what I was looking for. Okay, this gives me a 180. That's what I was looking for. That gives me a negative 180. That gives... Okay, so okay, rotating this way is... So in these two quadrants, it's fine, because this gives me a negative... This goes from 0 to negative 90, negative 90 to negative 180. But my upper one is... Okay, and this quadrant is fine, because that's 120 degrees. But then going this way is a bit difficult. Okay. So what's going wrong with that? I was pointing this way, and it's giving me 360 degrees too many. All right. So why don't we make this... I think the best way to change that... Let's see, so that's happening... So that's happening over here. I think the best way to change that is to say player angle equals... I think we just need to take the modulus. Player angle equals... Oops, excuse me. Player angle modulus 360 float. Okay. Let's try that and see what happens. Okay, currently I'm at 90. Rotate this way, I'm at 70, 60, 50. That's good. Hey, stay away from me. I'm trying to conduct a test here. No. Go away. Go away. Sheesh. Can't let me do some geometry in peace. Okay, I'm getting a negative there. All right, what happens in this quadrant? Negative there. Okay, wonderful. That is giving me the values that I expect. So then we're ready to do the conversion there. Okay, wonderful. We are 20 minutes into this recording, and I have gotten my angle set up. Let's see. Let's go back to our diagram here. So I've got the player angle. Cool. I've even called it player angle. Excellent. And then we're looking for the relative position vector. Okay, so now we need, let's see here. Determine whether ship is being chased by player. There we go. Player angle. Okay, cool. So the next thing I need to do is get the relative position vector. I think I can still... I think RVec is not being used for anything else after this. Yeah. Okay. So let's take our RVec that we've defined before. Have I defined an RVec before? No, I suppose I have not. Oh, I defined it in that loop. Well, let's just define it again. Vector to RVec equals, okay, what I want to do with this guy, I'm getting an error on him. No, I'm not. Alright, go away, error screen. No, I said go away, not be there permanently. There we go. Alright, so we've got a vector 2, RVec equals, alright, this guy needs to be enemy.pos minus player.pos. So I need to have transform.position minus player.transform.position. Alright, that's how I defined it up above. Thing position matches thing position. It's okay with that being a vector 2. It just ignores the z component. Excellent. I wish I weren't getting a local variable named RVec cannot be declared in this scope because it would give a different meaning to RVec, because I use a child. I don't know what you're talking about. So then why don't we do that? And now it's going to tell me it doesn't know what RVEC is. All right, then private vector2. Vector2. Okay, it doesn't like the use of the word private there. Okay. All right, we'll just have to run it and see what happens, I'm afraid. Because it's not getting me an error here, which it usually would if it were a problem. All right, so we've got our RVEC there. And now I need to get this thing's orientation. So I need to go through the same process that I went through here. So let's see, what shall we call that? Let's call that float RVEC angle. I should have done this down here with the black hole. Magnitude. Go to next nearest black hole. Yeah, I called it angle between black holes. Okay. Oh, right. Because this thing doesn't have a rotation thing. I have to do this myself. Okay. So I need to get this angle relative to the x-axis. So I need to take I just need to do it the same way I did it here, this angle between black holes thing. Right? No, no, I've already got this vector. I just need this vector's x and y components. Okay. All right then. So let's do this. Where am I? There I am. Okay. I need to call upon the arctangent. I'm going to call on arctangent 2 because that handles it takes care of the infinities for you with the tangent function. So I need to give it the y component, the opposite side. So that's going to be rvec dot y divided comma the x component rvec dot x. Cool. So I've got rvec angle equals that. So this will give me the angle between each of these. Oh, you know what just occurred to me is I'm already evaluating that in the player routine because that determines the angle of this thing. All right, now that error is showing up about RVEC, so it must not like that. Okay, fine. We'll call it something else. We'll call it, how about we call it PVEC for the player? Or more explicitly, player vector. There we go. Relative position between ship and player. There we go. So let's call this one player angle. Angle of relative position vector. And then I need to change those names down here. Paste and paste, save. There we go. It's not liking something. Player angle is already defined? Oh, I suppose I do have that. Oh, right. Right then, player vector angle. How about that? Sorry, I was raised on Fortran where you had to keep your variable names to length, I think it was like length 6 or fewer. Yeah, so that's a difficult habit to break. Okay, so then, looks like we don't have any errors currently, so that's good. Clear? Cool. So now we need to actually make the comparison. So let's see here. So we need to define our paranoia angle. So let's go ahead and define that up here. That's something associated with the ship itself, so we'll put it up here. And let's even make it public so that we can play around with it later. So public float paranoia angle equals, let's see, on my diagram here, so actually this is going to be like the half angle of the cone. So let's make that, let's say we make PA 15 degrees, so that way the total cone has an angle of 30 degrees. 15 times deg conversion. Have I defined that already? Yeah, I did. I defined it up here. Cool. 15 float. How do I describe this? Relative angle at which ship believes it is being chased by player. There we go. Cool. I should probably zoom in on this for you. There we go. Okay, so let's go down here. We've got this thing here is where we finally make the evaluation. So if mathf dot absolute value of, and now I want to take the player angle minus the not the player angle, excuse me, the sorry, player angle minus the player vector angle is less than paranoia angle. It's not liking, I think this needs to be in parentheses. Okay, so we're evaluating this, whether the difference between these two angles, player angle and the relative position vector angle, is less than the paranoia angle. Then we say that being chased equals true. Of course, I suppose there's an easier way to do that. I suppose the easier way to do that is to just say being chased equals this Boolean right here. And then I don't have to declare this thing up here. I can just say bool this. So let's let me cut the comment. That just saves, it saves one line of evaluation, which can be worth it. Okay. So we've now got a Boolean being chased. Ooh, I get a little flavor text there. Nice. So I guess that's a help text or something. Cool. So we've got bool being chased equals this thing. So let's have this thing print being chased dot to string. Cool. And so let's see. Controls. Oh, it doesn't like that. Probably because this thing is private. Well, you would want to be able to set that in the thing in the inspector anyway. So we would just have I can't do any calculations here, can I? We would just have paranoia angle times equals deg conversion. There we go. Does that make everybody happy? There, that makes everybody happy. Hooray. Okay. Let's see about whether the ship thinks it's being chased. Okay, the ship is not being chased. True, the ship is being chased. I'm coming after you. True. Right now the ship is not doing anything in response to being chased. True. False. False. True. False. That's cool. Wow, that's great. Okay. Let's do this. How long have I been recording? How long have I been boring these people? All right, we're about the half-hour mark. All right, let's do one thing before we call it a day. Let's use this to determine which behavior it engages in. So let's say if the thing is being chased. Okay, I think you have to put that in parentheses. If the ship is being chased, then what I want you to do is to... Oh, wait, that doesn't get a colon. Sorry, still in Python in my head. All right, so if the ship is being chased... Oh, maybe that was my problem earlier. Cool. Nope. Needs parentheses. All right, fine. If the ship is being chased, then it should go to... What did I call this thing? Go to next nearest black hole. Let's copy that. Go to next nearest black hole, and so I need two integers. I need the integer for the nearest black hole and the next nearest black hole, and I'm calling those closest black hole and next closest black hole. Okay. Because the idea there would be the enemy ship is trying to coerce the player into going too close to a black hole. Closest black hole, next closest black hole. Otherwise, avoid the closest black hole. Cool. So we finally got a little determination of the enemy ship's behavior. Oops. Let's put this thing. Let's put this view to the scene view so that we can see everybody. Can I get a zoom in? There we go. Okay. All right. So I'm going to be controlling in this window. Y'all watch in this window and see how his behavior changes. Okay, right now he's not being chased, so he's just avoiding a black hole. Now he is being chased, so he's going to go toward the nearest black hole. Boop. Oh, no. Well, I'm glad I have the gravity-free zone now. I haven't yet put in a check for whether the black holes are too close to the ship spawn point. All right, let's try to maintain chasing him for as long as possible. So right now he knows he's being chased. And so he is changing his flight pattern. He's not doing a very good job of evading me. What I need to do is I need to next make a code where he avoids the player ship. Oh, sorry, y'all can't see him anymore, can you? So let's see. All right, he's being chased. Boom, boom, boom. Okay, so I've still got a lot to work with in terms of the behaviors, but that does give us something to play around with. That does give us a possible way of changing the enemy ship's behavior, and it makes him a little bit more difficult to pin down. Okay, well that's a big success for today. I think we'll call it a day. I thank you so much for watching, and I will see you next time. Bye-bye.